Fume hood safety should be taken very seriously. You should regularly review the recommended safe practices listed on your LabConco fume hood's corner post. Don't be like Scooter. When using substances that produce hazardous levels of airborne chemicals, such as gas, fumes, vapors, and dust, make sure the selected enclosure is appropriate for the work you intend to do. Consult your safety officer for a reference on what type of safety equipment is required. The safety tips in this video apply to chemical fume hoods specifically. Scooter works with dangerous chemicals in inappropriate enclosures. Don't be like Scooter. Do not place your head inside the hood. The fume hood interior should be considered a contaminated space at all times. Don't lean into the contaminated fume hood like Scooter. Minimize drafts and sudden movements in front of the hood, because turbulence generated in front of a chemical fume hood can cause loss of containment. Locate hoods away from heavy foot traffic. Don't be like Scooter. Work a minimum of 6 inches inside the hood. Potential loss of containment increases significantly at distances within 6 inches of the plane of the sash. Place all hazards beyond this threshold. Don't keep your work dangerously close to the front of the work surface, like Scooter. He's living on the edge. Elevate equipment above the work surface. Elevated apparatus is much less obstructive to the airflow through the hood. Equipment left flat on the work surface interferes with airflow needed below to efficiently clear contaminants. Don't block airflow with equipment like Scooter. Keep sill and baffle unobstructed. The sill or airfoil of the hood is critical to containment, so avoid blocking it. All of the airflow through the hood eventually moves through the baffles at the back. Obstructing these baffles can cause uneven face velocities and potential loss of containment. Don't block the airfoil with notes, reminders, and other obstructions like Scooter. Do not use the hood for storage. Because hoods work more efficiently without obstructions, keep unneeded objects to a minimum. Chemicals should be capped and stored in the appropriate chemical storage cabinet. Scooter keeps things that he needed long ago and things he might someday need in his fume hood. And that thing. What's that thing? Adjust the sash to the smallest opening possible when in use. Locate the sash at a comfortable height just above the elbows and look into the hood through the glass. The sash glass should be used as a physical barrier to protect the user's breathing area whenever possible. Scooter likes to keep the sash wide open, says it gives him elbow room. You doing all right, Scooter? You look a little woozy. Scooter? Close the sash when the hood is unattended. Closing the sash completely protects passers-by in the event of a projectile reaction inside the hood. Additionally, in a variable air volume or VAV mechanical system, this improves energy efficiency. Scooter shows blatant disregard for his lab mates. Do not remove any of the hood components. Multiple components of a chemical fume hood are designed to manipulate airflow into and through the hood. These components typically work together in harmony, and a single modification can result in severe loss of containment. Scooter fancies himself something of a fume hood engineer, and he likes to make changes on the fly. Don't be like Scooter. Do not place flammable solvents near heat, flame, or sparks. If flammable materials and heat sources must coexist in the same hood, take great care in work practices and separate them as much as possible to avoid an accidental fire. Scooter recklessly places flammable solvents near heating devices. Do not evaporate large amounts of flammable liquids, especially in a low air volume situation, such as with the sash closed on a VAV mechanical system. Minimize the evaporation rate of flammables by keeping the vessels covered whenever possible. Scooter is a sucker for convenience, so he leaves flammable agent containers wide open. See you tomorrow, Scooter. If the lab is still here. Wipe up spills immediately. Spilling a solvent increases its surface area, evaporation rate, and probability of exposure. Scooter must think his mother works in the lab and will clean up after him. Routinely validate airflow. Proper airflow through the fume hood is critical to safe operation. Annual inspection of the face velocity with a calibrated instrument should be minimum protocol, and a complete ASHRAE 110 containment assessment is strongly recommended. Scooter doesn't know if anyone has ever done that, and he's not about to start caring now. If the ventilation system malfunctions or if the airflow alarm indicates an unsafe condition, close the sash, discontinue hood operation immediately, and call for help. Do not use the hood with biohazards or perchloric acid. Remember, your chemical fume hood is designed for a very specific family of hazardous substances. Working with biological hazards requires the use of an enclosure or cabinet classified for biological applications. The use of perchloric acid requires a fume hood designed and dedicated to the use of this specific, very hazardous chemical. Don't be like Scooter. Take protecting your laboratory environment seriously and pay attention to recommended practices when using any chemical fume hood.